I'm lead programmer on Team Z.I.P Ties.
My name is Krish, and I'm a programmer on Team Z.I.P Ties. If you guys want to tell us who you are for this, yeah.
Go ahead, AJ.
Oh, no, not me first. Hi, I'm AJ. I'm an FTA here in the Orlando area.
Hi, I'm Eric. I've been in first for way too long. I think it's going on 18 years. And I was a coach for 4 years, and I've done pretty much every volunteer job that First has for FTC. And I've enjoyed it so much when my daughter participated that I've stayed on this program and really enjoyed it.
All right, awesome. So I think we have a few things we want to talk about. The first thing would be sort of the game strategy coming into this game for some rookie teams and teams that are not as experienced, and even for more advanced teams. So what do you guys think is some of the best game strategy elements that teams can implement in order to score some points in the upcoming league meets?
My philosophy on that, especially for your first event, is keep it simple. You want to make sure that you can build a robot that can, do one of the scoring items and do it well. And then as the season progresses, get more and more capabilities on your robot. You don't want to try to build a robot that does everything right out of the box for your first event, especially if you're a rookie team. You want to be able to spend some time doing driver practice. I think driver practice is very important. And also giving time to the programmers so that they have enough time to program the bot and so that you can run and test it and do all the fun stuff that happen during events. You have to remember that you want to have fun at these events. You don't want to go into it and get all nervous and be stressed out. Just you're there to have a good time. Learn, and you're going to learn a lot by looking at other robots and looking at what the capabilities that they have. And if you think that you can mimic what they do, and fun at these events, do that for the next event, or try to. So that's what I would recommend.
And break that down a bit into like the different parts of the match too. Take that idea of just doing something to get some points on the board. Obviously, you're going to be doing that in teleup, and that's where most people focus first. But also think about that for autonomous too. Like, what is using the minimum number of lines of code? What is the way for you to just score something in autonomous? Because a lot of teams maybe don't even approach autonomous if they're in a league system and they're at their first league meet. They just sort of skip right over that and say, we'll worry about it later in the season. But you're missing an opportunity to get some points on the board and get some wins racked up early in the season. That can be very valuable.
Right. And another thing that I would probably say,
yeah, that's an amazing suggestion, especially with hybrid.
Go ahead.
Oh, I think our internet's a bit glitchy over here. But yeah, what we were saying is, especially for the auto portion of it, the tiebreaker 1 points will definitely come in handy towards like league champs, sort of championship time.
Right.
In fact, I think one of the questions we were wondering about was we realized that updating your driver hubs is not necessarily like required to pass inspection. However, we do want to know like what are some of the advantages of having an updated driver hub besides like the additional assistance.
This was for AJ.
Yeah, so this is a good one because I've talked to a few people about this because it's an interesting rule change, right? For a long time, we focused on, during the self-inspect portion of field inspection, making sure everything's up to date. And that was sort of a pain point during field inspection, is teams would come, especially if it's their first event of the year, have things that are out of date, And then we'd have to spend some not insignificant time getting everything upgraded. And it slowed everything down. It wasn't fun for teams for sure. And so I completely understand why First decided that we weren't going to do that anymore. But the trade-off there is now that you have more freedom to have older versions of software and use it in a competition legal way, you have to also have the responsibility to update it yourself and to give yourself help if you need it. Because as field staff, we cannot guarantee that we're going to be able to help you if you come to the field with an earlier version of any of the various pieces of software that need to stay up to date over time. It's just, maybe you're working with someone, a technical volunteer that this is their first year and they actually aren't familiar with the bugs and issues that come up in those older software versions. So you can't guarantee that you're actually going to be able to get the level of technical support that you may be used to if you don't go ahead and upgrade everything. There are some things that just straight up require you to upgrade the software. Like, you don't have a choice. For example, if you want to use the latest April tags library, you're going to have to at least get to the first official release of each new season for the first Tech Challenge SDK. That's a given. So there are a few things like that that you'll run into where you realize that we might as well go through the work to keep everything up to date because we keep running into these small things that require us to do it over time.
The other thing that I would say is that I tended to try to keep the version of our software up to date, because first fixes issues or bugs that are happening with the system, and you want to take advantage of those new updates. For example, last year they had a problem with the IMU. So if you had the previous version, um, you would run into some problems with that IMU. Whereas if you upgraded to the second or third release of it, I can't remember which, um, it fixed that issue. The other thing they found is they found an issue with the um, uh, static electricity with one of the components. So they created a fix in the code to resolve that. So keeping your versions up to date has some benefits, and in many cases they provide new functionality that makes your job easier in some instances also.
I want to give you a specific recommendation of how to do this, right? Because updating software is a risk. Don't get me wrong. Like, you may update it and find that they've actually introduced a new bug that affects the way that you use your robot. It's a small risk, but it is there. So my recommendation to teams in general is early in the week before a tournament, update everything. Give yourself enough time, meaning that entire week, probably, assuming you're going to a tournament on Saturday. Give yourself that whole week to test it out, have driver practice, make sure everything's working the way you expect it to, but you are at least up to date within that week. And do that for every single event that you attend. Most of them, once you get later into the season, there's not going to be anything to do. So it's not going to be too much of a burden. But especially early in the season, that's my recommendation.
Yeah, for sure. That's super helpful. I guess that's one thing that it nags on you, and then it builds up over time, and then you have to do it, and things just go everywhere. What are some other things that you guys would recommend teams do in the coming up to league meets to prepare for maybe the off chance that something doesn't work, or preventing those things from happening?
A couple of things that I would recommend preparing for a meet is run through the inspection process. Go through and go through the checklist and verify that you've done all the items on the checklist, that you have all the proper, cables, batteries, all of those types of issues for the before you get to the meet, so that when you go through the inspection process, it'll be a whole lot easier for you. The other thing I would recommend is um, the days before an event are probably very stressful. You know, make sure that when you get there, hydrate. Have some snacks. Don't be do you know do just do well. Um, One of my things that I wanted to always make sure that the kids did. I wanted the kids to make sure that the toolbox was organized.
Make sure that when you get there,
Because one of my
hydrate.
issues was, we could never find the right
Have
wrench at
some
the right
snacks.
time. When you're in the middle of something. So
Do
if everything
just
is
do well.
organized and you know where everything is and
One
what
of
you need,
my
it
things
makes
that
the
I
day a
wanted to
little
always
nicer in that respect.
If you're going on a road trip, this checklist is changing over time because our cars are changing, but there are a few things you should probably do. You should check the tire pressure on your car. You should check the oil if you're using a car that has oil, engine oil. Um, there's these things that you should just you don't have to check them all the time, but if you know that you're going to be using the robot in a very strong way, like going to an event, then there are things you should probably check right before you do that. For example, a lot of teams use mecanum wheels. There are little retention clips on the ends of the axles on the mecanum wheels. And fun fact, you can drive for an entire season with one of those retention clips missing and not notice that your roller is about to fall off. So maybe add that to your checklist before an event. Go through and check and make sure that all of the axles are properly retained and nothing's going to fall off the wheel. Um, yeah, things like that include going through and checking all the wires on your robot to make sure that they're actually plugged in correctly and they're not like loose or about to fall out, anything like that. Proper strain relief is something that we've talked about on here before. It's very important. And it's just basically taking a step back and thinking about, okay, I'm about to put this robot under a lot of stress. What are the things that might go wrong? And let's just set eyes on everything and make sure that it's in a good state before we subject it to that stress.
Yeah, and to just expand on that a little bit, one of the items that I always tried to make sure we did was labeling our wiring, um, because in the middle of a match, you're having to replace a servo or a motor. Well, where does it go? What connector is it connected to? Which one is which? So if you have a diagram of where all of your electronics are and where they're connected, that's a good thing. And that's also something that I always recommended the team put in their notebook, a wiring diagram. So it just makes it a little easier, and it shows that you thought about it and what it needs to be.
We also wanted to ask, like, are driver hubs often like they'll either like DC or like they'll turn off every once in a while, like even if you like touch them in the slightest? Is there any way to like say like avoid that issue?
Eric, if you want to vamp for a minute, I'll grab mine and show my piece of
Okay.
tape on the battery.
Yeah. There's a known issue with the driver hub battery with it being loose in the case that it's in, um, and there have been several different attempts by various teams to try to resolve that. I believe Rev put out a video of what they recommend to try to resolve that issue, but it still happens. Um, and if you have one of the Rev hubs that it happens more often on, my recommendation is to get a external battery also for that, and keep that battery, fully charged and running the driver station at the same time that you have that battery installed. So, AJ?
The problem Eric is describing is here's your battery, here's your driver hub. Battery sits in and it can move up and down within the battery compartment. And if it does that, it won't make good contact with those electrical contacts there at the bottom. So if you look at newer driver hubs, they ship with a small piece of foam, kind of where this tape would hit. It's kind of along the top, and it just pushes that battery down into the contacts. If you have an older driver hub, you can do the same thing by putting some tape on the battery itself. This is 2 layers of 1-inch white gaffer tape. It's just kind of around the top and along the side, and it just does that work of pushing the battery down a little bit more into the contacts. And that's really all it takes. It's just that little bit of extra, stuff in there to take up the extra space in the compartment and make sure that the battery doesn't move around too much. Now, using an external USB battery, like Eric said, is still a good way to go, even if you do that, because it's just going to make sure it's basically an uninterruptible power supply for your driver hub. And if you have the resources to buy one of those and keep it with you all the time, I recommend you just do it.
Yeah.
There's another issue with the driver hub, unfortunately, where it can just lose its wireless altogether. Like the wireless chip just turns off, that sort of thing. And unfortunately, there's no good fix for that. If you happen to have either you're a veteran team and you remember the days of using phones, or you just have a legal Android smartphone laying around somewhere, or you can borrow one from another team, I recommend having one of those nearby. Keep it as a backup with your operator console. So if that happens to your hub, instead of fighting with it and trying, to reboot it and you're burning minutes before the match starts, see if you can get your smartphone connected too. You'll need all the components that come with that, a USB hub with an OTG cable, all that sort of stuff. So it is a bit more to carry around, but in a pinch, it's a good backup for failing driver hubs.
And one other thing I would recommend, especially since the driver hubs have been out for several years now, um, if you have an older driver hub, I would recommend purchasing a new battery. I mean, just like your cell phone batteries, deplete over time and they don't hold charge as much, the same thing happens with a driver station battery. So, think of it as, as you buy batteries for your robot, buy a battery for your driver station is what one of the other things that I would recommend at the beginning of the year.
For more on the field wise, like last year, what are the one of the most common problems you've seen teams have electrical wise that have affected them a lot during the games?
Well, wiring is one of my pet peeves. um, and one of the things that we talk about is not proper wire management. You want to make sure that you don't have enough loose cable that it will get pinched, between rollers or pinched between your wheels, or brought into an intake. Zip ties are a wonderful thing. No offense. And that's one of the things. The other thing, like we said before, is labeling your wiring. Um, pop, especially this year, I think it's going to be very important. Is whatever mechanism you build, you're probably going to have some type of wire retraction capability. Either rubber bands or hook and loop or the 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 tubing, something of that nature. Those are going to be very important. The other thing you want to make sure of is don't leave wires just hanging out that other robots can grab. We've seen it in the past where two robots collide, and during that collision, you accidentally pull one of the wires, and you're down. Um, my favorite is probably leaving the power on off switch in a place that is very susceptible to being hit. There was one year where we had a robot that had the power switch right on the back plate, and like 3 times in a row, teams hit it, and we kept telling them they have to move it. And finally, we just said, we're moving it. We went over there and we moved it for them because we wanted them to succeed. So those are probably some of the things about wiring that I've seen the most.
The XT30 connections, especially on older expansion hubs and control hubs are getting up there in terms of number of years too, are a problem. If you're not familiar, there's two different ends of the XT30. One of them has these little pins inside, and it's like a little flower. And over time, the petals of that flower get kind of squished together, and so they don't make good contact inside of the cylinder that they have to make contact with. And there's a procedure that you can use. I think using a little pin is the recommended way to just sort of insert it in there and gently spread those petals apart again so they make good contact. But I have a stronger recommendation these days because it is sort of a persistent problem and it's so easy to break those contacts if you try to fix it. Use the other side. So do whatever you need to do to get yourself a cable that is, I don't know if you would call this canonically male or female, and I don't know on XT30 because it's weird. But get one that takes you from your battery to the other port on your driver hub, if that's what you're doing. Or if you're using a power distribution block, for example, make yourself a cable that goes from that power distribution block to the other port that doesn't tend to break. What will break in that scenario are the contacts in the cable itself. And that's a relatively cheap part that you can replace more easily over time instead of the more expensive part that is harder to fix.
Yeah, that's an awesome solution. That's something that we faced on a lot of our old expansion hubs. When we're testing around, we have to like bend the XT30 cable at an angle just to get the pins to contact. Yeah, that's awesome advice.
I actually
One
have.
other,
It continues. Sorry, I have one question after you're
you
done.
can go ahead.
So I have one quick question. We have a couple of issues with our servos, overheating, and what do you guys have about that? Like to fix an overheating servo?
So typically that means that you're trying to stress the servo and go beyond its torque capabilities. So you're trying to pull more weight or move more weight than what the servo is spec'd for. So if you're trying to hold the servo at a specific point and the weight that's on that servo is too much, that's going to cause that servo to overheat. So one way to solve that is by gearing the servo in some manner. You could do something of that nature, or look to see if there's a different servo that has more torque capabilities that you could use for in that instance.
Okay.
Just be very careful because
Yeah.
the new rules about servos actually specify the maximum output power and the stall current. So in past years, in a sense, you could get away with just going out and finding a much more powerful servo and just doing that, but not so much anymore.
Yep. And the other thing that I would say that probably may cause is, and we've seen this in the past when there are multiple servos running at the same time you're running multiple motors, your voltage is going to drop, and at some point it's going to reset your robot controller because the voltage on that robot controller is too low. So that is something you need to look for and make sure that that it doesn't happen on your bot. I've heard already of a couple of cases this year and a couple of scrimmages that I think it was on Reddit that I read that this team had issues with that, and they debugged it to having various servos running at the same time they were running motors, and their voltage dropped and they would reset. So that's something to look out for.
Okay. Yeah. Thank you. I appreciate that. Arnav, back to you.
Yeah, so bouncing off of what he said, would that be also caused by overrunning servos? I think one of the problems we might be having is going sort of the servo hitting something and trying to go past the limit. Would that also cause it to?
Yes, that's called what you're stalling the servo. Basically, you're hitting an edge and you're trying to continue to force it to go in that direction. That's going to cause it's going to try to draw more current to try to do what you're telling it to do. So it will overheat your servos in that respect. It'll also, at some point, it may even damage the gearing that's inside of your servos. So those may break, and then you'll have a servo that you just twist it and you don't hear any clicking inside of it. That's not a good thing. Especially originally with the old Tetrix servos that they had, those were notorious for that.
Regarding the robot, some issues that I was like, if we want a little input to the robot, and we stop that robot keeps giving like any driver output, do you know like how that problem could occur?
I'm going to say two things. One, it's either coding. The other, maybe you lost communication, and the last message that was received was that it was supposed to move. I think there's a third one that AJ has. Yep.
What I'm about to describe is the number one cause of that during a match specifically is when you plug this in, the very first time it gets power, that becomes 0, the natural state. So if this is upside down on your operator console and the joystick portion is being pressed, when you plug it in, that becomes 0. And so when it snaps back to the natural position, it's actually in a driving state, right? It's making your robot go around. So if you see that in the moment as a driver at an event, probably all you need to do is unplug and replug your joysticks. That's it. But that usually comes about because you are, setting up your operator console for a match, and it just, it's on the floor, it's upside down, something like that.
Thank you.
Now, did this occur, during a practice session, or was this just something that it started out that way when you got into teleop?
Like when we were testing our teleop, I think like once or twice it started doing that, but it hasn't occurred since. So I'm not really sure. Maybe we actually started putting the controller flat. But
okay.
Yeah.
The only time I've seen truly weird behavior come out of these control hubs and expansion hubs, where it just, locks up and keeps doing the same thing, is if there is a short in the data line of one of your either, I think I've seen it with the
motor
data
controllers.
line of a servo or of a sensor.
Yeah.
Meaning, either the 3.3 volt power going to one of your sensors and one of the data lines gets crossed, or one of them gets grounded out to the frame and it's always pulling down all the current to the frame, stuff like that. That is the time when I've seen robots do just truly wild things that they should never be able to do and lock up completely. So check all of your sensor wires and servo wires for just the smallest little nicks in the insulation that may be hitting the frame of your robot, especially if the wire is going around a corner, sharp corner. Go build a metal, it's pretty sharp. It can wear down that insulation. Check for exposed metal there.
Thank you.
Yeah, on the topic of shorts and the robot disconnecting and stuff, one of the things that we also wanted to mention is ESD, like electrostatic discharge. With robots that are all metal nowadays, what are some of the best ways that you can prevent this from happening to your robot, like during a match, and prevent it from disconnecting, shorting, things like that?
I have 2 specific recommendations for you. And the funny thing is that for the longest time here in Florida, it's kind of like, we don't know what you're talking about with this whole ESD thing, because it's so humid here that we don't experience the problem for most of the year, unless it's like, middle of January, we happen to get a cold front come through and it gets very dry out. Yeah, one day a year it might happen. But there's two things that you can do to help avoid this that I think are most appropriate for every team. First is to avoid any extremely long wires carrying data. So, for example, if you have a USB cable going from a camera to your control hub, make sure that that cable is as short as possible, because classically, if you have a super long cable that's all coiled up somewhere in your robot, that is a great entry point for electrostatic discharge into your control system. And that goes for really any cable. Perfectly lengthed cables aren't always something you can achieve, but the closer you get, the better you'll be. Um, and that just sort of speaks to a bigger thing about limiting the amount of interaction between the frame of your robot and the electrical control system in general. Uh, Anytime you have an opportunity to properly isolate one from the other is a good thing, with one exception, and that is the resistive grounding strap. This is what it looks like. It's just a little metal loop on one end that you screw into the frame of your robot, and an XT30 connection on the other end that goes into either a power distribution block or the other port of your rev control hub or expansion hub. Any of those will work. And all this is really doing, you'll notice that the XT30, it only has one wire going in, so only one side of that port is actually active. It's taking some of the extra, I'll just say stuff, extra static that builds up on your frame, and it's shunting it into, I believe, the negative side of the electrical system. So it's just taking everything that builds up and just giving it a place to go so that it doesn't go somewhere you don't want it to. I highly recommend, if you're doing an order from Rev or AndyMark, or after the next team update, there will be a third manufacturer that sells this kind of resisting grounding strap. Just throw one of those in there and put it on your robot. Now, since I'm mentioning this, I have to say one more thing about it, and that is this piece, it seems really easy that you just go ahead and put it on the metal frame of your robot and you're done. Um, but two notes. First, don't put it on a portion of the frame of the robot that's isolated from the rest of the robot. Like if you have one metal plate that isn't connected to anything else, that's not the place to put it. And also, most of the metal that you work with in First Tech Challenge has some sort of layering, some sort of covering over it. So you actually have to go through and scratch off the surface wherever you're going to put this so it makes true metal to metal contact. So it can actually, complete the circuit and shove that static where it belongs.
So one thing we wanted to ask, especially with this year, we have multiple programmers, and we were wondering about like what are some of the best merging practices when you're sort of using stuff like Git and sort of like not having to read through each other's code as much, or just making it more understandable overall.
Uh, um, One of the things that, especially with teams that have multiple programmers, um, and they'll build, like, for example, the programmers will implement different autonomous modes, for example. Um, I highly recommend as much comments as you can because during a match, um, or during an event, that programmer that made that code may not be there. So you may not know exactly what he intended. So commenting that code is very important. Not only that, but I, I sometimes had, we sometimes looked at, building programming cards, so we knew exactly all the different autonomouses, what they were, and then actually drew them out. So this autonomous is going to do this. This autonomous is going to do this. So when the people went to the field, they knew, basically what they were supposed to select in that in those various file names and capabilities, especially after talking to your teammates, to figure out what autonomous strategy is best for the instance of your teammates, because there are going to be instances where you're uh, paired with a team that is, a very basic bot, a rookie team, or you're going to be paired with a robot that's, a dynamo type of thing that does everything and anything. So you want to sometimes get out of their way, and let them be the case in that. So you want to make sure that you communicate with your partners. Have various autonomous routines that for different capabilities. You comment those. Um, Now in Git, um, I always recommend merge often is what I call it, so that you're up to date with the latest version of main in Git in that respect. So that all of your merge conflicts are going to be lessened in that case. They're not never going to be always gone. You're always going to have some merge conflicts. However, it makes it a little easier in that respect.
I challenge you. I challenge every programmer on a team. And I say this as someone who did programming for FRC, but let's call it close enough. Uh, Most of your programs should probably only be one file. I, there's an impetus from a lot of team programmers to sort of spread everything out, make many classes. Most of the time, that's not necessary. And there is a beautiful simplicity in an op mode that is just one file where you have your initialization, your startup, defining what's on the robot, the init phase where you get it out of the hardware map, and the code where you actually make it go. Like having that all together and having it read like a story in a single file is a benefit that you may not realize until later in your programming career. Comments are helpful in a situation where uh, you're working with other people and it may not be clear what you're trying to accomplish. You may go out and read online a lot of people saying that code comments are bad, that they're a code smell. And what they're trying to say is that if you have to type a lot of comments, it may be that your code could be rewritten in a more clear way. But they're saying that for people who all have the same level of experience. They're saying that for people who work at a company on a team where presumably they're all familiar with what they're working on and they have a shared context. And that's just not true on a First Tech Challenge team. You're coming in with people who have different levels of experience. Presumably in the next 4 years, definitely someone else is going to come in that's brand new and have to read it for the first time. So code comments are helpful. Having variables that are named well is helpful. If you have a variable that describes the timer that you're using to count down until this action happens, feel free to put some characters into that variable name. I'm getting off track. Sorry. I could talk about this for a long time. But having all of your code for an op mode in one file will improve your ability to interact with Git as well, because you won't run into as many merge conflicts. You're not going to have to reach into another portion of the code that is shared among many op modes and potentially cause an issue with everyone else who's working on that. It can be just a lot easier. I want to also recommend that you aggressively take that line where you are doing like at teleop or at autonomous, comment it out if you're not using that program, so it doesn't show up in the list anymore, so your drivers aren't confused about what they need to select. If you are using a program as a test or one-off, or you tried something and it just didn't work, just comment out that line. You don't have to delete the whole file, just keep it from showing up in the list of programs when you get to the field.
Yeah, so another thing, like on the topic of structuring programming and sort of like, working together as a team, one thing I wanted to ask you guys is what are some of the best ways you guys have seen in order to decrease loop times in your robot? Because as your auto gets more and more advanced, you want to keep on decreasing those loop times in order to get as accurate as possible. So what are some ways that teams can do this effectively.
I'm gonna sound 150 years old when I say this, but um, first of all, I want to challenge every team that your loop time probably isn't as important as you think it is in general. Um, the controllers that we use, I'll describe them as fast enough for what we're doing. Obviously, you're not going to fly a plane using one of these. Maybe if you work for Boeing, but not in general. Um, it can handle a lot, especially if you're using a Rev control hub. You're not going to have too much trouble. So don't focus on it too much. But if you do, understand what the heavy hitters are. If you're doing a lot of image processing, understand not just what that image processing is doing, but how it's doing it in terms of the new threads that it creates and everything like that. Because I think you'll find for most of the things that you want to accomplish as a team, that people making the libraries that you're using have been very smart about breaking that off into separate threads so it doesn't block all of the other actions that you're trying to do. Most of the time, you'll find that you actually don't need to do any additional work to make that happen and make it go right. But because we're on the topic, make sure you don't put, a wait timer in the middle of your loop, right? Like don't wait for a new value of a sensor, don't wait for anything if you are inside of like a while loop, for example. Let it go to the next iteration of the loop and then check again. And have the variables in place to tell like, hey, I'm still waiting for this, or no, I'm not waiting for this, you can do something else. So the next time it gets around to that iteration of the loop, it'll know what to do. And instead of just sort of pausing right in the middle of everything. Eric, do you have other
The
thoughts?
the other thing I would say is actually communicating to some sensors, especially if you're communicating over I2C, can sometimes take additional time in some instances. And like AJ said, for the most part, the type of stuff that we're doing in FTC, where we're, going to this position on the field, we're trying to, verify that we've touched this item or we're looking at one certain thing, having that, I'm going to call it a state machine that you program and that you build based on the sensor inputs that you see, changing over based on whatever you see to a new state, is probably the best way of doing it. So I'm like AJ. I wouldn't worry too much about trying to optimize your loop as much as possible. I would concentrate more on the functionality or the strategy that you're trying to build and the dynamics of that. Concentrate more on that than on trying to optimize your code at this point. Because you want to, move to this position on the field, move your arm up, score the element, come back down, come up over here, pick up something else, work on those types of items and those types of functionality more than, oh, can I reduce 3 instructions from this loop? It's really not going to affect you as much as you think, in that respect.
In terms of game strategy, we wanted to know like what are some of the best strategies you've seen out there, especially for teleop, like one person cycling or the bucket, or what would be sort of the best use of your time during that situation?
Um, I haven't seen any matches yet, so I can't really talk much about that. Um, However, um, like I said before, I think that um, having your drivers run and actually practice as much as they can is going to be something that's going to help you down the line. And my other recommendation is having a second driver, you know, also practice, because there's some instances where a driver gets hurt or gets sick or something. Having someone that knows how to run the robot and knows how to drive it the way you guys designed it for, is something that's very important.
with the buckets especially, but also hanging things on the I keep trying to call it the lander because I'm an old timer in FTC, the submersible. Um, there are plenty of cues on the field that can help you. So I think make your drivers' lives easier. If you have an opportunity to, for example, put a color sensor pointed down at the field, that right at the correct position where it will automatically stop the robot when you're driving up to the bucket, like the correct distance from the bucket. So the driver just has to drive forward and the robot will stop in the correct place. Imagine that future, right? Where they don't have to, kind of creep up next to it and, try and aim it or anything like that. That would be really cool. And then the robot can just score it and, make that scoring motion just a button press. Anything you can do to take the human element out of it and let the robot do the hard work for you is going to increase your cycle time and increase your point total. There are plenty of cues that will allow you to do that. I just mentioned putting a color sensor at the ground because I know there's a tape line right there, but it could be as simple as having something that's, after the start of the match, it comes out of the robot and hits the wall at the correct distance of where you need to be in order to score correctly with whatever configuration of arm, slider, etc. you happen to have. Make it impossible to fail, and you'll also make it faster.
Yeah, sort of on the sensors of, or sort of on the topic of using sensors in your robot and things like that. One thing that's really big this year, in addition to all the other changes, is the use of odometry. I know GoBuilda is selling their two-wheel odometry plus pinpoint. Um, SparkFun sensors come out. So with all of these, yeah, the SparkFun sensor. So with all of these like really new and really advanced systems for odometry and position tracking, what do you guys feel that teams should use it for? And also like what are the best ways to use it?
I think all of those products are great. I mean, I think all of them, produce similar results with varying levels of accuracy, but for the accuracy that we need in FTC, I believe that most of them will do the job fairly well. Um, if you're within half an inch or an inch of where you think you're going to be, that's a good thing for you. So in that case, I mean, of course you want it, you want to be as accurate as possible. However, um, so those all of those products can get you there, which is something that I like. Some of the newer ones, the new GoBilba uh, retractable one that goes underneath the frame.
Mm-hmm.
Um, that looks. I mean, but I'm not going to pay that amount of money. Um, but but uh, but yeah. So yeah, all of those products, anything, and truthfully for me, anything that makes programmers' life easier is a wonderful thing. If they give me a library to do all of this odometry stuff and to do everything that we need, and all I have to do is say, give me X, give me Y, I'm a happy puppy in that respect.
It's true. This year you have a pretty wide open field, to be honest. And the fact that odometry is easier than ever means that you can probably take the time to really learn how these things work and give yourself, like in autonomous, for example, every possible path you might want to take. It's so much easier now to do things like this that you can map out like every route you might want to take in autonomous and every way you might want to score and go ahead and just figure out what the odometry values are going to be for every one of those. And just, even if you don't intend to use them, you can still figure them out now and, stick them in a file somewhere. It's so much more flexible now than it ever was before, and it's worth it just to take the time to see what it can do for you, because chances are any new thing that you put on your robot isn't necessarily going to revolutionize how you do first tech challenge. We've hit a certain limit, And I don't think anything super major is going to come along and change your life. But over time, there are plenty of things that you may not realize could make your life easier. So just taking the time to work with it and really understand how it works, that's where the value is.
Well, I think that, when quantum vortexes come along, we'll we'll move into a new FTC environment.
Yeah, looking forward to that in our 2027 control system.
I have one final question for you guys.
Okay.
So, as far as the ascent goes this year, what are your thoughts on that? And how do you suspect, like, how do you have any tips or tricks on how to kind of lower your robot weight down to you know, be able to reach that third ascent zone?
Um, I believe that for the first match, personally, I would go for the first level and be able to score at that level. If you can, score at level two, the second bar, that's great. But I think that you want to, like I said, keep it simple for the first event, that's there. Strategy wise, I mean, I mean, if you look at, I think it's FRC from like 2016, 2014, 15, there was a similar type of uh, functionality that you had to do, game piece that you had to actually climb. So there's a lot of good examples out there that you can look at to try and build something.
Yeah.
And do the math. Take the difference between a level 2 and a level 3 ascent. Figure out what do you expect the amount of time it's going to take to get that additional level, and how much could you score in other ways in that same amount of time? Especially if you're, giving your alliance partner space to do their ascent first and you're just coming in at the last second, maybe it's worth it for you to go for a lower level and do other things during that time instead. So make sure you do the math on that and make sure that you're choosing the right way of going about it.
Yeah, thank you. I appreciate that. I think that's all we have time for today. Thank
Real
you
quick,
guys
yeah,
so much.
as we wrap up,
Yeah.
I just want to ask you guys, what are the top three things, just like straight out of your minds, that you think teams should do as the qualifiers start coming up?
Go ahead, AJ.
Oh boy. Um, get a resistive grounding strap.
Yeah.
Just throw it on. It's one of those things you can do it and forget it. My number two would be subscribe to my YouTube channel at FTAAJ on YouTube. Gotta plug it.
What I would say is, the before the match, before your next match event, take the time to organize all of your stuff. Make sure you take the time to charge all of your batteries before you get to the event. Don't be showing up at the event with depleted batteries or whatever. Um, you know, take the time to practice. Beforehand. There were many of times where the night before an event, at 2 in the morning, we had, the mechanical people finally gave us a bot that we could program. So we would spend half the night, programming that bot. So try to get things done a little earlier. And if you can't give them the whole thing, at least give them something that the programmer, something that they can work with, and try to prepare for that event.
Yeah, that's
Yeah,
awesome. Thank you so much.
thank you. Thank you guys so much for attending and spending some time with us and talking to us a little bit about this. We really appreciate it. Um, if you guys want to say
Yeah,
anything else before we head out.
I'm good. Thank you.
Subscribe to AJ, FTCH.
And make a checklist.
Uh,
Whatever it is, make a checklist.
make a checklist. I forgot
Thank
that.
you.
Okay, guys.
Bye.